This infrared image, taken by NASA's James Webb Space Telescope, depicts El Gordo, a cluster of hundreds of galaxies that existed when the universe was 6.2 billion years old. This view displays a clear assortment of unusual, distorted background galaxies that were suggested in previous Hubble images of the area. The El Gordo Galaxy Cluster is a classic example of gravitational lensing, where the cluster's gravity bends and distorts light from faraway objects behind it. Due to El Gordo's lensing, distant galaxies become brighter and appear larger, allowing us to see parts of the universe that would otherwise be too faint to observe. This lensing effect can also cause galaxies to appear duplicated or mirrored. One of the most prominent features is the bright red arc. Nicknamed El Anzuelo, or the fishhook, the light from this galaxy traveled for 10.6 billion years to reach Earth. Its unique red color is the result of dust from within the galaxy itself, as well as cosmological redshift, which refers to the redder hues from light waves that are stretched out due to their extreme increasing distance from us. The long pencil-thin line is known as La Flaca, or the thin one. It is another lensed background galaxy whose light also took nearly 11 billion years to reach Earth. Not far from La Flaca is another lensed galaxy containing an image of a single red giant star nicknamed Coir. It's nearly impossible to see lensed red giant stars without the infrared technology and sensitivity of Webb. Coir is the first individual red giant star observed at a staggering distance of over 10 billion light-years from Earth, and is the first of its kind spotted by Webb. With this new image of El Gordo, a gateway to groundbreaking scientific discoveries is unveiled, promising a wealth of new knowledge and insights into the captivating mysteries of our ever-expanding universe.
This is the Crab Nebula, located in the constellation Taurus, 6,500 light-years away. The Crab Nebula is a supernova remnant, a cosmic structure resulting from the explosion of a star. A vast, expanding cloud of gas and dust surrounds one of the densest objects in the universe, a neutron star. The Crab Nebula is made up of many components, including ionized sulfur, seen here in red-orange, dust in yellow-green, and synchrotron emission in a milky white. In the center of it all is the Crab's pulsar, a rapidly rotating neutron star. The pulsar has an incredibly strong magnetic field and rotates very fast. It produces a wind of energetic particles that we call a pulsar wind nebula. These thin, bright lines trace the shape of the magnetic field around the pulsar, which give the nebula its form. Fast-moving particles spiral around the strong magnetic field lines and produce a type of light called synchrotron emission, appearing here as smoke-like material around the Crab's interior. The outer parts of the remnant show remains of the exploded star blown out into interstellar space. This bright hot material was ejected at very high speeds and has fractured into intricate filaments and tendrils as it was pushed outward by the pulsar wind nebula. Here and here, the nebula appears to narrow. This abrupt slimming may be caused by the confinement of the pulsar wind's expansion by a belt of dense gas. With Webb's infrared sensitivity and data from past telescope observations, astronomers are gaining a comprehensive understanding of this region and its distinct and captivating complexities.
The Rho-Ophiuchi Cloud Complex, a small star-forming region, is located 390 light-years away, the closest star-forming region to Earth. A chaotic scene resembling explosions frozen in time, this new image from NASA's James Webb Space Telescope displays a field of about 50 young stars, many of them similar in mass to our Sun. A region that would look black in visible light is revealed in the infrared with Webb's sensitive instruments. The detail in Webb's portrait of starbirth is unprecedented. The scene is dominated by a giant cavity that has been carved by a single star. That star, S1, is more massive than our Sun and emits ultraviolet photons that have carved out a bubble. The yellow-orange color comes from tiny sooty grains that astronomers call polycyclic aromatic hydrocarbons. Streamers of gas and dust form structures and textures unlike anything we have seen before. The striking large red vertical band is a protostellar outflow, twin powerful jets of material that occur during the early stages of star formation. The projecting cone is the result of material that's been ejected through the jet. The entire structure glows red due to molecular hydrogen being energized as material from the jets collides with interstellar gas. Like most young stars, young solar systems also form in multiples, and we can see several brand new solar systems making their way into the universe via the very same processes that shaped our own cosmic home. Planet-forming disks block the star's light, casting telltale shadows across space.
NASA's James Webb Space Telescope has snapped this view of the pillars of creation in mid-infrared light, showing us a new view of a familiar landscape. Thousands of stars have formed in this region. This is made clear when examining Webb's recent near-infrared image. But in mid-infrared light, the majority of these stars appear to be missing. The pillars are flush with gas and dust. While mid-infrared light specializes in detailing where dust is, the stars aren't bright enough at these wavelengths to appear. Instead, mid-infrared light excels at observing gas and dust, like young stars that still have their dusty cloaks. These are the crimson orbs toward the fringes of the pillars. In contrast, the blue stars that dot the scene are aging, which means they have already shed most of their layers of gas and dust. How vast is this landscape? This bright red star and its dusty shroud are larger than the size of our entire solar system.